Hello everyone. In this video we're going to continue on in chapter 10, and specifically we're going to continue on with confidence intervals and hypothesis testing about the difference of two means when I can assume that my samples are independent of each other and that the standard deviations or variances are different in the two samples. And so in the last video, what we did last week, we talked about confidence intervals. And so now we're just going to go do the hypothesis testing part, and then we'll work into the other two situations in which we can find ourselves in when we test. And those will be independent samples when you can assume equal variances, and then dependent samples. But we'll get there in time. And so when we start out with a hypothesis test, or these slides that I'm going to go through, are going to be the exact same steps of the hypothesis test that we did in chapter 9, both for P and mu, but now we just have two samples, and we're looking at the difference in means in our specific situation. Okay, and so first step is the optional step of stating your parameter of interest. And so, of course, it's going to be problem specific, but we're always looking for the difference of two means. Step 2 is always going to be, of course, to identify the null and alternative hypotheses. And so in this case, the null hypothesis is always that the two means are equal. Okay, so the two population means are equal. So it's always mu1 is equal to mu2. Okay, and then the alternative hypotheses, you have three choices, and that's all based on the statement of the problem. Either mu1 is less than mu2, mu1 is greater than mu2, or that mu1 does not equal mu2. Okay, and so we have all of these, we have these three different null hypotheses, and those, of course, change how our problem is done. But there they are, the null and alternative hypotheses. Third step, level of significance, like always. You state it, it's usually stated in the problem, so there's some easy points. Step 4, the assumptions. And the assumptions for the hypothesis test are going to be the same as the assumptions for the confidence interval that we did last time. And so those assumptions are: the data is taken randomly for both samples. We have independent samples from each population, and specifically we have unequal variances. And then third, both distributions are normally distributed. Both population distributions are normally distributed. Okay, and so again, none of these right now are really checkable. Can we actually check these assumptions? Not really, but later on we will. I will teach you how to check some of these assumptions. But right now we just have to kind of take them as they are. When we actually get data and not summaries, that's when we can do it. So we'll get to that in just a little bit. So that's the assumptions. Step 5 is the critical value / test statistic. Okay, and so this is where it changes. And so the test statistic for a two-sample test for difference of means, blah, 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 blah. We have a whole bunch of situations here. Independent samples, unequal variances. This is the test statistic. X bar 1 minus X bar 2, which is the sample. I'm testing... Actually, another way that you could have written the null hypothesis is that the difference of the two is equal to 0. That's the same thing as saying mu1 is equal to mu2, correct? So if they're equal, then their difference is 0. And then I could write the alternative hypothesis like mu1 minus mu2 is greater than 0, or less than 0, or not equal to 0. And so this is important to understand, because here in our test statistic, we always have the value of the test statistic, or sorry, not the test statistic, the value of the sample statistics, X bar 1 minus X bar 2, which is just the version of the sample version of mu1 minus mu2, minus the hypothesized value. And so here, the hypothesized difference in the null hypothesis is 0. And so that's where that 0 comes from. Okay. Then in the bottom, what we talked about last time is the standard error of the sampling distribution of x bar 1 minus x bar 2. Okay? And we found that that was s1, the square root of s1 squared over n1 plus s2 squared over n2. Okay? So that's our test statistic. Then we calculate the p-value, and that p-value changes based on what the alternative hypothesis is. So I give you the 3 options here. So if the alternative hypothesis is less than, then you find the probability about the test statistic here, which has a t distribution. It's the probability that t is less than t. For greater than, it's greater than t, and for not equal to, it's 2 times some probability. Okay, and so we don't really need to worry about actually calculating these because Minitab will always calculate it for us. Okay, and so in that way, this is easy. Step 7 is the decision and the conclusion. Okay, and both of those are problem specific, so I won't talk about them now. But let's look here, before we look at an example, here's a nice summary from the book. They put this out. It doesn't have all the steps, but it has most of them. The hypothesis, test statistic, p-value, and conclusion, also the assumptions. Okay, but there's a nice thing if you need to print out and look at it. When you do questions, this is a nice summary of that information. Okay, so let's do an example. This is the same example as the one we did for the confidence interval. It's talking about whether men or women want to have more children. And I want to use the same information, which is captured in the table here, to do a hypothesis test to see if women want more children than men at the 5% significance level. So we'll start with the null and alternative hypotheses. The null hypothesis is always that mu1 is equal to mu2, or that there's no difference. And then based on what I say above, I want to see if women want more children than men. So first, I guess I need to define mu1 and mu2. We'll say the first one, mu1 is women. So mean number of children for women. Sorry for my terrible handwriting. And then mu2 is the same, but for men. Okay? And so if I want to test if women want more than men, I'm going to test if mu1 is greater than mu2. Okay, so those are the hypotheses that we're going with. Significance level is 0.05. Assumptions that the data was taken randomly. We have independent samples with unequal variances. And then third is both population distributions are normally distributed. Okay, sorry for my terrible handwriting again, but hopefully that makes sense. All right, step 5 is the test statistic. And I don't necessarily need you to write down all of the work because at this point we have to go to Minitab. So let me move to Minitab here for the test statistic. to Minitab. We're going to go to Stat, Basic Stats, to Sample T, and we did this similarly for confidence intervals. We have got summarized data, and so sample size for women is 921, for men 754. Means were 2.54 for women and 2.5 for men. Standard deviations were 0.89 for women and 0.85 for men. Okay, and so then we want to go to options. Hypothesized difference is always going to be 0. Okay, but technically we could do we could test for how much greater than it is, but we won't really get into that in this class. Okay, so it'd always be 0 there, and we're testing if the difference between mu1 and mu2 is greater than 0. Okay, because our alternative hypothesis was that group 1 was greater than group 2, and so that means the difference between group 1 and group 2 is greater than 0. Okay. Again, we don't click the Assume Equal Variances button because we can't assume equal variances. So we click OK, I click OK, and then we get the output. So down here, this is a confidence interval, but we're interested in the test. The test statistic is 0.94, so you can just write that. Test statistic is t equals 0.94. Okay. The p-value is 0.174. Okay, because the p-value, and I'll talk through the rest of our example. Because the p-value, so you write down the p-value with a probability statement. Okay, but you write down the p-value. The probability that t is greater than 0.94 equals 0.174. Since the p-value is greater than alpha, I fail to reject. Okay, greater than alpha, I fail to reject. And then your conclusion is, at the 5% significance level, there is not enough evidence to conclude that the difference, or that that women on average want more children than men. Okay, so again, just for our sake, you'd have t equals 0.94 is the test statistic. P-value, probability that t is greater than 0.94 is equal to 0.1174. Decision is, since the p-value is greater than alpha, we fail to reject the null hypothesis. Conclusion, at the 5% significance level, there is not enough evidence to conclude that women want more children than men. That women want more children than men. So children than men, and really you should add on average at the end because we're talking about means. Okay? And so that is how you would do a hypothesis test. And so for your turn, I give you another example here. Okay? Actually, sorry. So let's see, the your turn before was about the confidence interval. Now you use that same information to test if the wage gap is present. Okay, if women get paid less than men at a 1% significance level. Okay, and so that's the your turn for this time. Full hypothesis, step 1 through step 7 or step 8. Okay, and so that's what I want you to do for next time.